Good evening, everyone. So request you all to log into joinpd.com and just type out this code. It would be on the top right corner of your screen so that we can make the session interactive. As of now, only few have joined. So we'll be waiting maybe 5 more minutes and then we'll start. Is that okay for everyone?
Yes, sir.
Yes, sir.
Yes, sir. Okay, so have all of you gone through the lectures of week 9 or anyone still over here who hasn't completed the lectures? Is there anyone like that?
No, sir. No, sir. Lecture had completed.
So in general, what was the idea, like people who are doing
No, sir.
beginner level?
No, sir. I haven't
Uh,
completed the lecture yet.
okay. No, those who have completed, what would be your idea about the lectures? Like it's all new topic for you people. So did you find it tough, or was it moderate level, the concepts?
They were of moderate level.
Okay. Were there any confusions in any of the lecture slides or something? Like where you didn't get the idea from week 9?
No, sir. No problem in the lecture.
No, sir. No
Great.
problem in it.
Okay, great. Okay, so I think 2021 students have joined in. So we'll start today's session.
Sir,
Yes.
sir, when will the quiz to revision session start?
Okay, so the revision sessions would be basically starting from tomorrow. So most probably tomorrow there will be a summary or revision session for 2 weeks, and then Thursday would be another 2 weeks, and then Friday we are planning to have a PYQ. So we'll get in all the previous year questions related to quiz 2, and we'll try to make you solve all those. Okay, so that would be the plan for this week, starting from tomorrow.
Sir, but the paper is on 2.
Sir,
Sir, what would be the syllabus
please
for
schedule.
Q2?
Sir, please schedule the class revision class earlier, so we get time to get revision.
The revision will start from tomorrow only, right?
No,
Sir?
just
Mm-hmm.
Sir, what would be the syllabus for Q2?
Week 1 to 8.
So, sir, week 9 won't be there.
No, not only
Okay.
till week 1 to 8. Week 9, doing it today, the sole purpose is because you have to also submit the graded assignment, right, for week 9.
Yes, sir.
So it is just to help you people, whoever hasn't, because of quiz preparation, maybe there are people who haven't gone through the lectures or finding it tough to solve the assignments. So just to so that those people can get benefit out of this. So that's why we thought of us getting week 9 done, and then from tomorrow onwards we can target it solely for quiz preparations. So 2 days it would be revision sessions, and then the last day it would be PYQ.
Yes, sir. Random variable is quite tough comparing to other weeks.
Yeah, and mostly because it's a, you'll see that for your quizzes, the release of the weeks won't halt, right? So
Yes,
it
sir.
will
Yes.
keep on coming. After this, also week 10 would be released, and then 11, week 11. So you can't be lag behind in any of those weeks. So it's better you just at least have an idea about whatever is taught in week 9 and not just focus solely on quizzes.
Yes, sir. Yeah, that's correct. Sir. But we have to focus for quiz two only from week 1 to week 8.
Correct, not week 9. Week 9 to that would be for end term. You can start preparation
Yes, sir.
after that. Hmm.
Thank you, sir.
Okay. Okay, so those who join these sessions regularly, you know how to put in your responses. Like anyone who doesn't have an idea about the peer deck or how to get into join PD and start answering the questions. Okay, so for each question, you'll be having an option to put in. So basically, just as I was talking, that there may be people who don't have who haven't gone through the lecture. So that's why we had planned of having this week 9s today. So the thing is, let's say in general, what is random variable? Those who have gone through the lectures, can you tell me like what is the difference between a normal variable and this what you would have studied in week 1 or 2, and what is the difference from that variable to this random variable? Like in very simpler words, if somebody asks you that what was the use of introducing this thing random variable, anybody who could explain it?
Yes, sir.
Hmm? Yeah, carry on.
Actually, what happening in statistic is like we just only saying about the probability of event. We're not saying
Hmm.
about the exact thing. Uh, I'm giving you data of India and saying that the murder of data, but you just looking the data and saying, oh, India is a great city, India is a great country. Then, when you are entering the very dangerous state like UP and any like that, then you find out, oh, that is not correct. So that for reason we need to like a variable so that it will define our the exact probability. So that we need to run a variable. Also, it stores the many of outcome like.
Okay, yeah, almost correct. You can just frame it in
Sir,
a better way. Okay. Others, anyone?
let's say there is a family and there are total, we can say that 5 people. So if we start from a family, it can have 1 people, then 2 people, 3 people, 4 people, up to 5 people. And we are just trying to solve the probability of how, let's say if 1 people, then P of X is equals to 1, I
Okay,
guess.
just I'll modify this thing. So both of you are correct, but just to put it in a better way, you can say, for example, this last example, what you were saying, right? That family. Let's say that we can tell it this way, that in a family, let's say there are 5 people. Okay, so Ram, Sam, Hari, and maybe Jack and Sita. Now these 5 people are living in one family. Now these all 5 can be in my sample space, right? Let's say if I ask you to define the whole sample space, anybody of you would write just all the 5 names, correct, as a set. Now,
Yes.
in general, these outcomes are okay for mathematical solving anything, but are we able to extract any meaningful thing out of it? Like for example, you can have an analyze from the same sample space or the same outcomes, for the same family members. I can give you one variable. I can define one random variable on this. That let's say how many are girls and how many are boys. Okay, so in this, the sample space is still the same, but now I am analyzing that my concern is that I have to find out number of boys and number of girls. Whoever may be the name, I'm not concerned about the name of those family members. What I'm concerned is with how many out of those are male and how many out of those are female. Right. So this can be one different analysis. Another analysis can be in total how many family members are there. In that case also, I don't care about the name of those family members. Who are those people exactly? I'm just concerned about that. How many are those? Like I think the last person who said that We need the family members can be a single family member, or we can say 2 family members, 3 family members, and accordingly we'll add on different people, right? So my random variable can be that once I can put my x, I can define my x to be that number. X can be the number of males in the family. Another time I can put x as a random variable, that how many total members are there in the family. So the sample space is still the same. That is the number of possible outcomes are still the same, that 5 people only, Ram, Sita, Hari, Jack, and whosoever the last 2 people. The sample space is still the same, but still I can put different analysis on the same sample space. Once I am analyzing that how many are male and how many are female, the other time I am analyzing that in a family how many members are there. So I am literally putting some meaning to my outcomes. I'm not just exactly means arbitrarily randomly giving out some outcomes from an experiment. Ultimately in probability, what we are doing some random experiment, and from that random experiment we'll be getting out some outcomes. But just those outcomes doesn't make sense to me always. For me, if I'm analyzing in real world something, then that makes sense to me. For example, you let's say your brother gives, or your brother or sister gives you a die, and they're asking you that what is the probability that how many I can get a 6 out of it, or maybe greater than 3 out of it. Now, as a normal example, solving a numerical, you can just say that all possible outcomes are 1, 2, 3, 4, 5, 6. But why am I doing it? Why do I need to find out what is I should have some aim for doing those things, right? So one thing can be that I want to analyze that what is the probability that I can, anytime I roll this die, can I get a value greater than 3 or not? So that can be a random variable which I'm analyzing. So that random variable I'm imposing on my total sample space, and then I'm analyzing that variable, that what are the possible values this random variable can take. So this is what the sole purpose of introducing random variable to any sample space or any outcomes in general. There's the most important use of having random variable is this only, that it gives a meaning to my outcomes. I can means assign some numeric values to each possible outcome, and then I can analyze those numbers specifically. Like if I'm as I was saying that let's say if my random variable was number of males in the house, then I can easily analyze just that okay, my number of males can be 0, number of males can be 1, number of males can be 2, and what will be the probability of those. And basically, when you go to higher statistical courses, you will see that most of the cases you are not exactly dealing with these outcomes. You are dealing with these random variables only. And that would be the random variable. Okay, so now till this, it's clear to all?
Yes, sir, clear.
Okay, so can you tell me, is random variable a function or not?
Yes, sir, it may be function.
So what kind of function, and if it is a function, what should be the domain? And I think you all have done maths on, or you must be doing maths on parallelly, right?
Yeah.
So
So
It's
what?
domain 0 to 0, not all real numbers.
sir,
Okay.
can I
Depends on
Sir,
Okay.
natural numbers.
One at a time, please. Okay. Any one of you just would. Yeah, tell.
so it
All
depends
real
on the
number
random.
according to me.
Okay. Those who want to say the answer, just raise your hand. I'll call out each one's name, and then you can answer. Okay, Chetan. Yeah, carry on.
So it depends on the random variable, how we define that random variable.
Hmm.
If we define it in a certain way that it can only take discrete values on the real number line, then the domain would be the discrete values, and uh, I think the outcome, the output would be the
The range.
probabilities. The
Uh,
range, the range would
yeah.
be the probabilities.
The range of the function would be in the interval between 0 to 1, right?
Yes, sir.
Your
Yes.
domain can be anything real number. But again, one more thing to just add on in this, that your random variable is always defined on the probabilities of my sample space, right? That
Yes.
you can't have something out of your sample space as your means random variable can't take any value out of the sample space, right? Means it's a, you consider the random variable as a box, then through one side you will be giving inputs to your outcomes only, right? And from the
Yes.
other side, you'll be getting some arbitrary values. For example, if like say, if you are finding out the sum of two values rolled in a die, then from one side the input you will be giving is, let's say in the first die you got 1 and in the second die you got 2, and the output you will be getting out as 3, right?
So
Okay, one thing I saying, okay, sorry, one thing I missed out is that no, the range won't be 0, 1 for this case. That is, we are talking about another function which will come on later. For discrete random variable, the domain can be your whole sample space, and the range would be any real number, right? It can be both discrete
Sir,
and yes.
okay, okay, sir. Okay, sir. Sorry, sir.
No, is it clear to you, right?
Yes, sir.
Because see, as I was talking about, that the input you can give is anything from the sample space, right? Any sample outcome from the sample space you can give as your input, and the output depends on how you define that random variable. But that can be in the real number line, anything, right? It can be only the discrete values or the continuous variables, right? But we are not considering about the probability as of now. That would come later. So is the domain and range of a random variable clear to all? And it's where the function is defined exactly.
Sir, this is not clear for me.
Okay, so what I was talking is that first thing is random variable is a function, right? You will give some value as input and you will get something output as a any value as an output, right? Till this it's clear.
Sir, how we are relating a random variable to a function?
What is a function basically? Function is something that is giving you some values. If you give input any value, it can work on that. You can means you have depending on the definition of the function, you will get out some values out of it, right? Or it is a
Yes.
link between your domain and range. You can say it that way also. Correct.
Okay, sir.
So similarly, tell.
Sir, till now, what I have studied is random is just picking something within a sample space.
Correct.
That is random variable. So still
Correct.
I'm able to connect the function concept and this concept.
Okay, I'll tell you. See, you are saying what? That random variable is arbitrarily we can take something out of the sample space, right?
Yes, sir.
But are we taking directly the events? We are something modifying those events, right? For example, if I say the random variable, as I was saying, let's say the random variable is defined as the sum of the values you get in the rolling two dice. Okay. So, and
Okay,
say
sir.
let that, and when you roll the two dice, you get 1 and 2 as your values. So what would be the random variable x?
Sir,
Let's
your
say,
voice is tracking.
is my voice clear to all or it is breaking for others also?
Clear, sir. Not breaking.
Oh,
Okay, is it clear now to others?
Your voice is clear, sir.
yes,
Sir, voice
yes,
is clear.
now it is clear.
Okay. Okay. So what I was saying is that whatever would be your outcomes from the sample space, if you pick one outcome, then that is what you are giving as an input to your function. That is the random variable. Let's say if I'm giving, as I was saying that if you are rolling two dice and you are getting two values, 1 and 2. So now this 1 and 2 are my input to the random variable x. And now if I've defined my x in such a way that I will make the sum of it, those two values, then I will, obviously if I've given input 1 and 2, the output I will be getting from the function or the random variable is 3. Now I could have defined the random variable in other way also, that what is the difference between the two dice I am throwing. Now at that time it would become 1, right? So what I'm saying is that my domain for this random variable is all my sample outcomes from the sample space. And now range can be anything. It can be on that, it can be anything on the number line. If I am defining it somewhere that I'm adding it, maybe I'll get some discrete values. Maybe if I'm defining it some other way, maybe I'll get in continuous range in some in some interval, I can get any arbitrary value, right? So it is actually behaving like a function to us, where I'm defining it on the whole sample space, and then I'm collecting some outputs from that. Okay.
Okay, sir.
Is it clear to all now?
Yes.
Okay. Okay. So similarly, I think whatever rules were there or the definition was there for the random variable in week 1 or 2, that what are discrete variables and what are continuous variables, the same way, because it is ultimately, again, it will take some values, right? Now those values, if they are discrete points in a number line, then it would become discrete random variable. And if it you can define those values in a certain interval, then it becomes continuous random variable. And now the random variable, whatever values they are taking, if they are involving in counting, then obviously that would become a discrete random variable. And if it involves kind of measuring, because if you can take arbitrarily any infinite number of possible values in an interval, then it becomes continuous random variable. Is this clear to all? Or anyone any doubt which should be a discrete and continuous? Okay, so we'll do a question related to this. Yeah. Just can you give out the responses quickly? Of the 16 people joined in, only 8 have responded. Others, please do response. Okay, low responses. Okay, everybody is given me only. So like anybody, why do you think the B and C are not the right answers? Anyone?
We
Sir,
have to measure.
Okay, I think Chetan, you can explain the B part, and Sanjali, you can explain the C part. Go on.
Sure, sir. For this B part, sir, time taken by a person to write an exam, it is something that we measure, not count. We measure the time, and it can take any real value on the real number line. So that is why it's not a discrete random variable. It will be a continuous random variable.
Great. Okay, Sanjali, what about the
sir,
C? Hmm.
the weight of a person can be like if someone had 56.33 kg, it can be a means continuous variable, and discrete means a separate, like 1 2 3,
Correct.
which is
For
not C.
example, let's say, just to assume that let's say a human body cannot be more than 100 kilos, just for assumption, then a person can have any weight in between from means till 100, right? We can't exactly define that only he will have 50 kg or 60 kg or 70 kg or 55 kg. He or she can have 55.5 also, 55.6 also. There are infinite possibilities in that interval, right? So that is why
Yes,
it's
sir.
continuous.
So it is same as continuous data and discrete data, huh?
Yeah, exactly. How you used
Which
to
we
analyze the
studied in
different.
the first week.
Exactly. It's just that now the variable is taking some values which is dependent on the outcomes that you are feeding into your variable, right? As I said, it's a function. So you are feeding something and then you are getting out a value. But that value can be again discrete or continuous, anything, right?
Right.
Okay. So now, as I was talking about, I think Chetan or somebody said that when we were talking about random variable, the range for the random variable was something like what were the probabilities value. But actually, that would be the case for probability mass function. Okay. So, okay. Anybody who would like to tell what is a probability mass function?
It's the distribution of probabilities for a random variable. The probabilities it can have.
Okay. Okay, that's correct. Anyone else something would like to add on?
Yes, sir. Yes, sir. I add something like probability mass function is need because for finding the probability of discrete random variable. So that we need PMF, and it could say it is say about the first of all is say that the sum of all probability of every like a random variable is 1, and every probability is greater than 0.
Okay, those are the properties. We'll go back to discuss about those later. But in general, what is a probability mass function is basically, okay. First, tell me in this thing, this is clear to all that this is also a function, right? We'll just try to break the name first. Let's say this is also a function. Now, why it is a function? Because again, probability mass function is defined on, if anybody would like to say, what would be the domain and range? Anyone?
So domain will be
Actually,
again
sir,
samples
greater than equal.
based on the sample space.
Not exactly sample space. Over here, we will be talking about the random variable, right? So the random variable, for the random variable, you can think it as a step-by-step thing. Okay. First, see, you did the experiment, you got some output, correct? You got the output. Once you got the output, you define a random variable upon that output. So in that, if that random variable is a in box, then one side you are giving input, the output, and then you are getting out of that box some arbitrary numbers, let's say. Now those arbitrary numbers would become your domain for the probability mass function. So we will be defining our probability mass function on the values that the random variable will take. Okay, because if you see, for example, over here you see na p of xi. This xi is what? This is the value that the random variable will be taking, correct?
Yeah.
So my domain would be actually become what are the possible values that the random variable can take. Now those those values that the random variable can take indirectly are coming from the outcomes only, right? You must have defined your random variable function in such some way that you are feeding some outcomes and you are getting out some values. But for us, when we are defining the probability mass function, we are only concerned about what are the possible values that the random variable can take. For example, let's say if you are defining a random variable x, same thing if you are rolling a die, let's say, and we are saying the random variable x is defined that whatever the output we are getting on rolling one die only. So what is the possible values x can take?
1 to 6.
1 to 6, right? So the
So
I'll be defining.
sir, one concern is suppose the experiment was not done for long duration, not about dice. Let's say there is another example where experiment can give if the fair values are, let's say, 1 to 100, but we did experiment only till 80, right? And we did not get whole range. Then domain will be only those whatever outcome we got, only those will be its domain, or it will be still be 1 to 100.
No, see, the thing is, whenever we are doing those experiments, there are a lot of assumptions that we take. Okay. But in general, what you are saying, that whatever you will be getting the outputs, all the possible outputs, that is what your domain means, sorry, that those are the only possible values x can take. Okay. Or else it depends on the experiment to experiment. For example, let's say if you are saying, for example, tossing a coin. So it is natural common sense that you know that you will get head or tail. Maybe you might have toss the coin 5 times and somehow the coin is biased or something, and all the 5 times, or maybe you had some unlucky day or something, that all the 5 outputs are head only. Okay.
Yeah.
But that doesn't mean that you will say that I can't have tail for this random variable, right? Because it's a known fact that for this random experiment, these are the all possible cases. So it depends on case to case. But if there is no predefined thing that you don't know what are all the possible cases, then you will solely depend on only on the outcomes that you would have got in that experiment. Okay.
Okay.
Okay. So the domain thing is clear. Now the range, what would be the range? Because it is talking about probability. So your it would be only between the interval 0 to 1, right? Because we can't have probability values exceeding 1, and we can't have also have negative probabilities, right? So it would be in the interval 0 to 1. So what is the sole purpose of this function? The sole purpose of this function is that it will tell you that, let's say, for example, probability of xi. So when we are means not probability, when we are talking about the PMF of xi. So in general, if you have to put it in words format, then we are saying that it will give you the probability of x taking the value, random variable x taking the value xi. Correct?
Yes.
Is this clear to all? This capital X is my random variable and it can take any value. So let's say the arbitrary value be xi. So when we are defining the probability mass function, we'll say that it will give you the probability of random variable taking the value xi. So this is how it is defined. You can get an idea from this that my domain is actually what are the possible values the random variable is taking, the capital X. That is okay. Now we can define some functions. Some properties for this probability mass function, because a function can be arbitrarily defined in any possible way, right? But when we are talking about probability mass function, we are predefining that this is how my probability mass function should look. Else, any arbitrary function I'll not consider as a probability mass function. So what are those predefined properties? That for any value, it should be greater than or equals to 0. And whatever the function you define it, it should be defined in such a way that all the probability values would sum up to 1. Because ultimately, if you see why, what is the logic behind defining these two properties? First thing is probability, right? So it can't go less than 0, any probability values. Now, second thing is why it should all sum up to 1, because ultimately we are taking the random possible values for the random variable, right? Now, if you see, where will this random variable get the values? Random variable will get the values from the outcomes only. Now, all the possible outcomes, the probability of all these possible outcomes sum up to 1 only. So ultimately the PMF will also sum up to 1 only, because ultimately if you see the chain, only some specific outcomes only can come to my random experiment, random variable, and then those random variable values will only contribute to my probability mass function. So ultimately if you sum them up also, it will come to 1. Till this, is it clear to all?
Yes.
Okay. Okay, so we'll do using those properties only. Just try to solve this. Okay, till 50% only attempted this. Others, can you just type in your responses? Why are you not typing out? Just basic properties, whatever we discussed till now, 2 properties, you have to use those only. Okay, let's move to the responses. My goodness. Okay, so there are 50% who are saying yes and 50% no. Anyone from the yes team would come out and justify why they are the right one?
Sir, it's an infinite series. So a by 1
Okay.
minus r, it comes out to be 1. So that's why it's a PMF.
Okay, so for some people, it's an infinite series and solving it, you are getting PMF to be 1. That's why it's an valid PMF, right? That's what you said, right?
Yes, sir.
Okay, and yeah.
Sir, it is an infinite series, so it will go to 0, and the rest will not have the sum 1. Means all of these values will not get the sum 1.
Okay, so you are saying it will infinite series, so it will go to 0 and we won't be able to sum it up to 1.
Yes, sir.
Okay. Anyone
Can
from
I
the
try,
no
sir?
team anymore? Justify.
Yes, sir.
Yes,
Yes,
sure.
sir.
Hello. Hello.
Yeah.
Hello.
Hmm.
Yeah, I said no, sir.
Yeah. Yeah. Okay.
Yeah. I
Okay, one at a time, please. Others, can you just mute? Yeah, carry on.
can I continue or somebody else?
Yeah. No, Vanshi, don't carry on.
Oh, okay, sir. So I found the solution to be like, there is a infinite number series 1 plus x squared plus x cube. I use that formula 1 by 1 minus x there, and I
Okay.
got it to be like 1.8. 1.883 to be the answer, and so it is more than 1. I said it is no.
Okay. Okay, we'll see. So basically, you all are saying that infinite series is a must thing. Some are getting it to be some other values and some are getting it to be 1. Any other inputs, or this is the whole crux of it? Anyone else who was trying to say something, you can say no. Okay.
Actually,
So
if you add it, can I speak?
yeah, sure.
Yeah, what I'm saying is if I take, it seems to be a, I think, infinite geometric series. So in that case, I think it should be 1 by 6, that comes to 6. So 5 by 6 into 6, it comes to 5. So sigma pi is coming out to be 5, which is against. So that we can look in one way.
Okay, we'll move to the solution. Let's see which team wins. Still, we have 7 each, so we'll see. So the solution to this is something like this. See, but the thing is, you have what are the possible values x can take? It can take infinitely any number, right? 0 means it's a discrete random variable, so it will continue 4, 5, 6, 7 infinitely. Now the thing is, let's apply any possible value to it. 5 by 6 into 1 by 6 to the power, let's say 0. So what would be the first number we are getting?
5 by 6.
5 by 6. For the second number, will be getting 5 by 6 into 1 by
1 by
6.
6.
What would be the third number we'll be getting? 5 by 6 into 1 by 6 whole square.
Whole square.
Correct. So in this case, what okay, look, I think your voice is breaking.
Sir, I made a mistake in making the first term in the numerator. I think it should be, I have taken it, if I take 5 by 6, it comes to be 1. That is no.
The first thing, it starts from 0, right? So first term would become only 5 by 6.
Yeah.
Okay, so can you all see that it is becoming kind of a form of a, then ar, then ar square, then ar cube, where A is my 5/6, and then my R value would be 1/6. Is this clear till this?
Yes.
If you see, the first term is I'll be getting 5/6, and then the second term becomes 5/6 into 1/6. Then the the third term becomes 5/6 into 1/6 whole square. Fourth term would become 5/6 into 1/6 whole cube. So my R value is coming out to be 1/6, and it's an infinite series of AR geometric infinite series. Okay. So for infinite geometry GP, in the formula is A by 1 minus 1 by R. So from there, can you solve this part? That because 5/6, okay. So over here, what they've done is that 5/6 they've taken out common. You can do it in another way also. That as I was saying, 5, and then again your R would become 1/6 only. So is the solution clear to all? And you'll sum it up to 1 only. Anyone who didn't get the solution part of it? So it's an valid PMF, right? Because we are summing it up to 1 only. So it's a valid PMF. The no team, is it clear to all?
Yes, sir, it's clear. It's a calculation mistake. What I did is calculation mistake.
Okay, no issue. Okay, so we'll move to the next one. Okay. So using the same similar properties of PMF, can you just try to solve this one?
Done, sir.
Okay, it's a basic calculation, just others also please try it out. Only 4 have responded as of now.
Is there somewhere like we have to put our answer or we need to put that in the chat?
No, you can join through joinpd.com, and then if you see in your screen in the top right corner, there's a code. Just type it down in that whatever the login page you'll be getting, and then you can it will ask you a prompt to type out your answers over there. Just log into joinpd.com. It will you'll get an idea from it.
And what is the code that I need to use?
It's you can see in the top right, MKJXBB.
Okay, okay.
If you
Okay. Yeah, I can
did you
see
get it?
Yeah.
Okay. Others, please submit your responses. Only 50% till now. It's the basic properties, just it's normal algebraic calculation. That's it.
The summation of xpx has to be 1, right? Xi,
Summation of px has to be 1. Yes, right.
not x into px.
X into px is not what we are looking for over here. That is expectation value. I don't think that has been covered in week 9 till now. Did you?
Yes, sir.
Did the
Yeah, I
professor
would.
say anything? Yeah.
Okay.
No, we are not talking about x into px. We are just talking about the properties of the probability mass function as of now.
Hello. Am I audible?
Okay. Still anyone trying? Yeah. Yeah, I wanted to ask something. Okay, so I'll move to the responses. Okay, so maximum is given 0.1 only. Okay, so anybody would like to just explain what are the properties that we need to use for this question?
Sigma p of x I is equals to 1 to n is equals to 1.
Yeah, the summation of the all the possible values for the random variable, summing up for the probability mass function
Is
values
1.
will equal to 1. Okay. So from there, if you do it, because the possible values are 7 only, right? For this, if you see, again, going from the basic thing, that x can take the possible values are 0 to 7. And then this probability mass function is defined on these possible values. And these are the probability values for it. So we'll just keep on adding those values and we'll equate it to 1. From there, you'll get the k value would be in quadratic form. So we'll be getting 2 roots for it. So one would be negative and okay, why is k value not negative taken? Means why?
Probability cannot be negative.
Yeah, so because the probability values are itself defined in the form of k, right? So if you are taking the negative k values, then automatically you are assuming that the probability values are less than 0. So which is violating our properties, right? Okay, so we'll move to the next one. Yeah, the repair continuation to the last question. Okay, anyone trying, or shall we move to the solution?
No, sir. No, sir. No try.
Anyone trying? You are trying it?
No, sir. Solve it.
Okay. 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 See, the first thing over here again, whoever is given this 2.35. See, ultimately, whatever may be the condition, the random variable be, but ultimately your probability values can't exceed 1, right? Because whatever way you do it, it's just a probability value. So if anyhow you are getting calculations and it is giving you something greater than 1, then definitely you are doing it wrong. Okay. Okay. So now for others, what should be the approach for this? Like you already have got the k value to be, I think, 1/10. Then how to just calculate for x less than 6?
Sir, 0 to take px
Cumulative
to 0 to 5
CDF.
Yeah.
and
You
add
can,
all these.
correct. You can do it through CDF also. Basically, it is in a way of saying that I will try to find out the CDF of x equals to 5, right?
Yes, sir.
Yeah, that is one way of saying it. Or other way around of saying this is also that I'll sum up all the possible values where the random variable is taking less than 6. So what are the possible values? Random variable can take 0, 1, 2, 3, 4, and 5. And then I'll just sum up those probability values.
Sir,
Okay. Yeah.
sir, we can also do it like take a px to 6 and 7 and add both of them.
You can do that. Then you have to subtract it from 1 also, right?
One. Yeah.
Yes, sir. Yes, sir.
You can do that.
Thank you, sir.
Okay. Is this clear to all?
Sorry, how did you say?
See, either this way, say just
No,
go
the
through
last
this.
one that girl was telling, right? So,
Yeah, so that is what we will do the complement ways. That if you are finding out x greater means less than 6, then we can also write it that probability of x means 1 minus probability of x greater than equals to 6 also.
okay. Yeah, because
That,
total is 1, so yeah, okay.
yeah. Yeah, this would be the next one.
Sir, can you send me the previous question? Actually, I got disconnected.
Yeah, this is the question. The same continuation, just
Question
need
number,
to. Sorry?
The question just after that probability mass function, which is the geometric series, infinite geometric series.
Okay.
The next question at the solution, because I got disconnected.
Yeah, this
Yeah.
is the solution.
After that, there is no question.
No, we have done, I think,
Oh,
two
the next
questions.
question is this one.
Yeah, this is an interconnected one. So
Okay.
we've almost
So after
solved
that,
two
the
of
infinite
them.
geometry series is the next question.
Correct.
Okay, fine.
So you can do it from here only because the data are almost same
And
only.
solution, send me the solution.
You can
these
submit.
These
Sorry?
already, so this year getting discussed now, no?
Yeah, correct.
Okay, fine. Then I'll do it in that case.
Can you show me the solution for the question 2? I just need to see the solution. What are the steps?
Question 2 means the subpart of this.
Yes.
Okay. Yeah, this is. Is it okay?
Yes. Now you can go to that.
Sir, can we move a little faster?
Yeah, the quicker the responses come, we can move faster, but we have to see others also, right? Okay, anyone all done with this question or?
Yes, sir, done.
Okay. So for this, what would be the possible values you will take? Tell me.
Just
Zero to
subtract
4.
the probability for 5
1, 2, 3,
from the
4.
previous.
1 to 4.
1 to 4. Okay. So, okay, just out means nowhere related to this. I was seeing the probability mass function. See, okay, you all are in this data science course, okay, and ultimately the basic core thing is your statistics only. So let's say a friend of yours asks you to define an experiment, wants to analyze something, and then let's say you go to a cricket tournament, and over there you are analyzing for let's say your friend is asking you that in that tournament in an over how many times what is the probability that in an over the run scored is more than 6. So what should be your approach of solving this question? In the tournament, a friend of yours gets to know that you are doing a specialized data science course, and then he asks you, can you just find for me that what would be the probability that in an over a team can score more than 6 runs. You don't need to tell me the exact values. I'm just asking you what should be the process related to how will you define the random variable for this experiment? What should be your experiment? What are the all possible sample space outcomes you will be considering for your sample space? Just a very rough idea. Anybody?
Sample space would be all the number of runs he can take in a over, and
Yeah,
the
the
random
number of
variable
yeah, carry on.
the random variable would be that he takes more than 6 runs in that over.
Okay, more than 6 runs. So what are the possible values your random variable can take?
1, 2, 3, 4, 5, 6, and to max 36.
Max 36. Why max 36? Okay, in an over, the maximum run
Yeah.
can be 36.
Yeah.
Sir, won't
Okay.
we use a Bayes theorem based on the previous one particular over? How was the score for this particular player in a similar conditions, right? It's a maybe naive ways we can use, right? So based on past.
Okay. Bayes theorem is okay. I'm not talking about that. I'm just talking about what are the possible ultimately for applying Bayes theorem also you need to find out the total probability values, right?
Yeah, but we need a historical probabilities for that, right? For similar games. Yeah.
No, okay. Okay. That way that you have some prior knowledge and then whatever the likelihood you are getting, then you can update your belief. That is okay. Others, I don't know if you all have gone through naive Bayes. So we are not talking about that. We are just talking about that specific match. Okay. In general, we are not trying to find out an inference out of it. So we'll not go to that part. We are just talking about that specific match only. Okay. We are not talking in general that whatever you are saying, we could have given that approach that in general, whatever my belief is that how many possible runs can be scored in a over. And again, it depends on like, is that over being bowled in before the power play or not? You will have some prior belief about that experiment, right?
Yeah.
And then you do that experiment and you will update whatever you will get the likelihood from that you will update it. But we are not talking about all those. We are just talking about in that match seeing the outcomes or in that experiment, whatever the outcomes are happening. And from there you are trying to find out the probability. Okay. Designing it that way, yeah, it's logical. We have to consider too many things as we are not in an advanced statistics course. We are forgetting about those parts. I'm not going into those details. I'm just asking you that how will you design this experiment in general? That's it. We are not basically we are not even concerned about the how to find out the probability values. Just what can be all the outcomes and all. That's what I'm asking. And how will you actually use a random variable in your experiment in general? That is the whole idea of asking this. Okay, so I think Chetan or some who said that answer that the 36 possible values for X.
I said that.
Okay. So anyone join in, add on something for this?
So, but if we take 36, then so what he's proposing is each ball is fetching 6 runs, right?
No, each ball not. It's that total run in that over.
Sample space is for me is from 0 to 36.
So there is equally likelihood of fetching 6 runs on each ball, right? So that is what you are proposing with 36.
Yes, there is one possibility of scoring 36 runs also. But what should be my sample space? My sample space is not runs in each ball, right? It is the sum of the runs in an over. Yeah. Correct. So my sample space can be that in the whole over, I can have 0 run also. Yeah. And it can continue till 36, right?
So if I ask you P of 1 to 3, for example, right?
Okay.
So what should be the answer with that? Let's say we model our random function based on our this function based on what he described, right? So it will be still 6 plus 6 plus 6, right? 36.
A small question. I mean, I'm not very familiar with cricket, not a big fan, but I know that for one ball, we can hit a 4, we can hit a 6, but what are the maximum number of runs we can run for one ball?
No, but where is the randomness here? That's why I'm asking. So, so
Uh,
if we go with maximum,
no,
you know,
no, that is just I have just defined the sample space for it. What are the
Okay,
possible values it can take?
I'll
Uh,
tell you where is the randomness to it. So first answer to Chetan is that we don't need to go into the intricate rules of the sport. Okay, just a very basic surface idea I'm trying to implement about random variables. So what are the possible ways? We are not even concerned about getting out the exact probability values. Okay, so you don't need to think about what are the exact rules of how much possible. Yeah, very general, that in a ball the maximum score can be, that is 6. Okay, we'll assume that and move ahead. This is the first thing. Now for this, whoever was asking about the randomness thing, see, for us, the randomness comes that we as an observer, we need to know that what is the run scored in that over. Now, is there a possibility, can you guess it exactly that what would be the total score? Yes, you do have a upper limit to it and a lower limit to it. That the lowest score that can happen in an over is a maiden over, that is 0 runs. And the maximum, if we are assuming that in each ball the maximum score is 6, it can go to 36. But still, even if knowing the minimum and maximum value doesn't give me the power to exactly guess that what would be the possible runs in that over, right? There will always be that uncertainty. It can be any possible value from 0, discrete possible value from 0 to 36, right? That is where the randomness comes, that we are not able to predict exactly the outcome of my experiment. I can get any, that my outcomes are over here from 0 to 36, anything, but I'm not able to exactly predict what outcome I'll be getting when I will be seeing an over. So that's where it becomes a random experiment. Is this clear? Whoever was asking, is this clear?
I think it was Sanjay sir.
Okay. Okay. So this is one thing, but okay, one way of
So
defining
can
the
we
random.
say can we say that this is as good as throwing a die? Because throwing a die is also 1 to 6, is also 1 to 6. You can have any runs between 1 to 6. You can have 1, 2, 3, 4, 5, or 6, and this is also same. So that's why
Yeah, you
36
can
outcomes.
see there are different ways of modeling an event. Okay, you can even say it that it is like rolling 6 dice consecutively, right?
Right. Consecutively
So
6 dice.
yeah, it's up to your imagination how you can means if you think it this way also, that where in real life we don't get this tossing a coin or rolling a die, right?
Right.
But actually you can model these real life things into these smaller simulations, and you can correlate, and that would help you in solving those questions which you will be facing in real life. So like for example, this is a good way of saying it, that you can actually model that whole over into just throwing 6 dice.
So it is
And
almost like, sir, in a book cricket, what you do is you can
Sir,
correlate this with a die throw. So if you throw die 1, so you have scored 1 run. So you can correlate this with a book cricket, and then you can define the runs.
yeah, you can correlate with whatever this toy examples we do in the books.
Right.
You can actually correlate with those.
sir, is it
But
really
there,
that similar to dice throw? Because in dice throw there is equal probability, right, for each event. But here we know that uh, chances of getting a lower run is much more than the chances of getting a 4 or a 6.
No.
no.
They all are same. There is
We are
no. You can score a 1 run. You can hit a 6, and both are same probability, because there is
okay.
nothing
So
called
I
this
low.
think
is no.
I think
This
that
is
is
one
where
thing.
the experiment comes, right? So experiment is a game of a cricket here.
Right.
So that is
This is one thing I would like to tell to everyone, that you, whenever you are solving these questions, whatever beliefs you have to keep it aside. Just think it through the data. Never, whatever assumptions you have, never involve those. See, Chetan, you are assuming that you know the game, and that's why that scoring a 6 run is tougher than scoring a low run that may be 1 or 2. But we will not take our beliefs into account. Okay, we'll just consider that everything is equally probable for us,
Sure.
unless and until it is mentioned in the question that this player is more probable of scoring a bigger run than maybe less probable of scoring smaller runs. Then it is given in question to us. But we can't assume anything from our side. For us, it will be equiprobable, everything. Okay. Okay, now one more thing which I wanted to add on is that this is one way of defining the random variable that, okay, my x can take 0 to 36 any possible values. But I can also tell it another way, because my idea, if you remember that I said you, for my friend, the concern is that what is the possible, what is the probability that they will score more than 6? Correct. More than 6 runs in an over. So I can also define my random variable in other way possible. That is, my random variable can take just two values, that is 0 and 1. Like, can you tell how? Anyone who would like to tell?
I think
I
0
can,
for yes and 1 for yes. If he hit
yes,
the ball,
exactly. If in the over your sum is coming up less than 6, that is 0 or 1 or 2 or 3 or 4 or 5, I will equate that value to x equals to 0. If I am getting any value greater than 6, that is 7 to 36, I will equate that value to my random variable x equals to 1. Now, I can also say that probability of x equals to 1 is equivalent to getting all the possible values, like probability of x equals to 7 plus probability of x equals to 8, probability of x equals to 9, everything, right?
Yes.
So exactly that was the main idea of saying, asking this question, that your random variables can be defined in any possible ways in the same experiment. It depends on what is the ultimate goal you are looking for. Okay. Is this clear to all?
yes, sir.
Okay. I think I skipped one. Okay. So this is the next question. Okay. So from here on, Farhad would be taking. So you can start solving this.
Okay, someone is asking where do we type the answer. So you can see that see this link at the top right corner, mkjxb. So you can go to this website joinpd.com. There you will get an option of joining a session. There enter this code. So then you will be able to see a console where you will be able to enter your answers. Okay.
Sir, can you go to the answer?
Yes, we can, but let's wait for a few more people to solve. Okay, I will start discussing the solution at 7:24, 7:25 will start with the solution for this question. Okay, now is everyone done with the solution to this question? Anyone is still
Yes.
solved? Okay, now I
Done,
think
sir.
given you enough time for this question, now let's come to the question. Okay, let's first read the question. Naman has to give 3 mock tests. Okay, the probability that he will not give any mock test is 1/8. The probability that he will give 1, 2, 3 mock tests are 3/8, 3/8, and 1/8 respectively. Let x be a discrete random variable which represents the number of mock tests given by Naman. Okay, so what has the question asked? What is the probability that he will give at least 2 mock tests? Okay, now even if we were not given that this x is a discrete random variable, it was pretty easy for us to like know this is a discrete random variable since it is talking about number. Like I think you all might have gone through this. Whenever we are dealing with number of things, we come to discrete random variables. Okay, that's different topic. Now let's come to the solution. What it has asked us is that he has 3 mock tests to give. Okay, and the probability that he will not give is this probability. He will give 1, 2, and 3 mock tests that are also given. Now the question has asked that what is the probability that he will give at least 2 mock tests. So at least 2 mock tests mean either he will give 2 or he will give 3, right? So as we approach the other questions as well, let's first draw this construct or draw this probability mass function for this question. So It has been given like X is a representing number of this X is representing a number of mock tests given by Naman. So he can either give no mock tests, that is 0, 1 mock test, 2 mock tests, or 3 mock tests. And it has been given that the probability he will not give any mock test, that is 1/8. The probability he will give 1 mock test, that is 3/8. Probability that he will give 2 mock tests, that's also 3/8. And probability that he will give 3 mock tests, that is also 1/8. Now to check if this is the correct PMF for this question, we will sum up these probability values. Okay, it's always very good and good idea to check this, because sometimes we might have made a mistake, so we can rectify our mistakes at the earliest stage only. So 3, 3, 6, 1, 8, 8/8. So this is a valid PMF for this question. Now, the probability that he will give 2 mock tests is probability X taking values equal or greater than 2, right? Either 2 mock tests or 3 mock tests. So we can break down this probability X is greater than equal to 2 as probability of X equals to 2 plus probability of X equal to 3. Either he will give 2 mock tests or he will give 3 mock tests. So probability of X equals to, that is very evident from this table, that is 3/8. And probability of X equals to 3, that is also given in the table that was given in the question, 1/8. So solving this, we get our answer to be 0.5. Now let's see what all responses we have got. Okay, there is one surprising response, 3. Okay, so whenever you are dealing with probabilities, like this is the basic, this is from the basics, that our probability cannot be greater than 1. So if you got your probability greater than 1, then check where you have gone wrong. Okay, so most of the solutions are 0.5. Okay, 0.57. So someone had entered this in 0.57. So be a little careful, because I had asked, the question had asked up to 1 decimal accuracy. Okay, so be a little careful of such questions in the exam. And you'll have exam there, see how many decimal accuracy, up to how many decimal accuracy the question has asked. Any doubt in this question? Anyone?
No, sir.
Okay. Now let's move ahead. Okay, now what is RCDF? We have, up to this point we have discussed PMF, probability mass function. Now what is our CDF, cumulative distribution function? So what a cumulative distribution function is, like our probability mass function, what it was giving us, or why we used to deal with that, is that it used to give us probability of X taking a particular value, right? So in CDF, it's not. So what CDF gives us is the probability of a random variable taking a value equal or greater than a given value. Okay, suppose in in this, let's see here. Here it was given as probability of X is equal to 0. So we were taking values at a particular point. But in CDF, it's giving us we are dealing with probabilities greater than or equal to some point. Okay, that is basically CDF. It also takes values in 0, 1, and it's represented, how we represent it is f of X, where what this X denotes, it's the point probability of X taking less than or equal to value to this X. Okay, and these X1, X2, whatever those are, these are like the value a random variable is taking. That was just a brief introduction about this CDF. Now, yeah, you guys can try out this question.
Sir, can you go to previous slides?
Previous slide? Okay.
Yes, sir. This one.
Okay.
Thank you, sir.
Okay, someone has raised their hand. Do you have anything to ask?
Yes, I have a doubt.
Okay.
Uh, yes, not regarding this question particularly, but regarding this topic. So
Sorry,
suppose we are
your
given.
voice is breaking.
Yes, sir.
Your voice was breaking a little. Okay, now it's fine.
Oh,
Yeah.
sir, yeah. Sir, actually, suppose we are given like here we are given probability at 1 and probability at 2. And by this we have to find like probability of x less than equal to 2. So suppose it is other way around and we are given probability at x less than equal to 1, probability at x less than equal to 2. And then we have to find probability of x is equals to 2. So sir, then how will we approach? Like suppose probability at x less than equal to 1 is 1 upon 10 and probability of x less than equal to 2 is 5 upon 10. So sir, if we have to find probability at x is equals to 2, so how will we approach it?
Okay, this is not related to this question. Let's solve this question. When I finish this question, I discuss that as well. Okay.
Okay.
What is this F3? Is it the probability 3 or the F3 is what?
F3, as I just explained, this is the CDF. Have you gone through CDF, cumulative distributive function?
Yeah, right.
So it's that F3 is equal to probability x taking values less than or equal to 3. Okay.
Okay, fine.
2 more minutes and then we'll start the solution of this question. So everyone who's solving, just hurry up. Okay, is everyone done with the solution?
Yes, sir.
Okay,
Yes, sir.
let's discuss this. Okay, what we have been given is x. It is given that it is a discrete random variable with the following probability distribution or probability mass function, as you know. Now, x take, we can see that from this given distribution, x takes value either 1, 2, 3, or 4, right?
Yes, sir.
Okay. Now, what is so we can see from this we have been given this probability of x value, the PMF, in terms of a unknown constant k. So the first step will be to determine this k. How we will determine this k? We know that summation of these probabilities is going to be equal to 1, right? So 1 by 4 plus 4k plus k plus 1 by 8, that will give us 1, right? So let's move to the solution now. Then what we have to calculate is f of 3. For calculating that, we need to know these probability values, these 4k, k. So the first step would be to first obtain what this k is. Okay. Now, as I just said, that the summation of these probabilities, the PMF, it gives a summation equal to 1. So 1 by 4 plus 4k plus k plus 1 by 8, it equals to 1. On solving this, we'll get 5k equal to 1 minus 3 by 8. Okay. taking the LCM and taking this constant term to the other side. From here, we get our 5k equals to 5 over 8 or k equals to 1 by 8, that is 0.125. Now, half of the question is done here. So we now know what's the value of k. Now, what it has asked us is f of 3. What this f of 3 is, this means probability x taking values less than or equal to 3, right? So that will be probability of x equal to 1 plus probability of x equal to 2 plus probability of plus probability of x equals to 3, right? That is how our CDF is defined. This f of 3 has been defined. F of 3 is equal to probability of x taking values less than or equal to this 3. So we know that will be 1 by 4 plus 4 times 0.125 plus
0.875.
yeah. So on solving this, substituting the proper values, like I just said, f of x is probability of x taking values less than or equal to this x. Here our x was 3 as it was given in the question. So it will be probability x taking values less than or equal to 3. So that will be probability x taking value 1 plus 2 plus 3. So substituting the values of these respective probabilities, we get our f of 3 equal to 0.875. Now let's just have a look at the solution, the responses. Okay, nice. Most of the responses are here 0.875. Few are here 0.125. I think they have entered the value of k. They have done half the question. Okay. Any doubt in this question? Okay. Now to the next question. I will also discuss that. Okay, check this. This is pretty simple. Somebody had asked that if we were given that value at certain between f of x is less than we were given the value, how we would obtain the value at the particular point. I will get to that as well after these questions.
Okay.
Done, sir.
Sorry, I did not understand. So this is x has 4 values, is it? 4, 5, -1 and -8?
Yes.
Okay, and for all these values, it is x by 16.
X, whatever this x, yeah, it will be x by 16. This is pretty simple, right?
Yes, sir.
There is a catch here. You can see this. We don't need to check anything in this question. Okay, I don't think anyone will get this wrong, even if this, okay. For those who have entered yes, just carefully look at this x and probability of x if you substitute these x values. Shall we discuss the solution now?
Yes, sir.
Yes.
Okay, I have 2 yes, and for them, I'll just like to make this clear. This is not a PMF. Would anyone volunteer to say why this is not a valid PMF?
Negative probability.
Yes, exactly.
Sir,
So we
because it has probability -1 by 16.
Yes, exactly. So we know that our probability is given by x over 16, whatever value this x takes. So hence from this, we can see that our x is taking value -1. So the probability corresponding to this probability of x equals to -1 will be -1 over 16. But we have been studying probability for long enough to remember and know that our probability cannot be negative, right? It lies between 0 and 1 inclusive. So the probability will be -1 by 16. That will definitely be less than 0 or negative, in other words. So this cannot happen. So this is not a valid PMF, right?
Yes, sir.
Exactly. And just a moment, there was someone who had asked this about the CDF. Have you been given a
Yes,
CDF? Okay. Now, have you gone through this CDF questions, activity questions, or all that video lectures?
yes,
Have you?
yes,
You know, like when we are given a CDF, we have been given the like few points. F of A equals 0. A is less
yes,
than 1, or A
yes.
is less than 2. So from there, it is pretty easy to make a graph of this, right? And we know the graph
Mhm.
of the
Yes,
CDF
the
is
graph part. Yes,
basically our step function, right?
step
There,
function.
it's
Yes.
like a staircase step function. So suppose now you were to find the value of, suppose x equals to 2. That is what you want to know. Like, how do I calculate
Yes,
the value at a particular point?
yes,
So you will get a graph at equals to 2, right? There will be one step, right? One,
Yeah, there will be a step.
right. So what you will do is you will calculate the size of that step. What by size of step, what I mean is you will calculate the upper value minus the lower value. Suppose at
Lower.
x equals to 2. So whatever you get from that, that will be your probability at that given point.
Oh,
Okay.
yeah. So, sir, suppose like x is less than equal to 1 is 1 by 10 and x is less than equal to 2 is 5 by 10. So step will be of 4 by 10 because the gap is of like 4 by 10. So
You
that will
first,
be the problem
yeah, you first need to like formulate that accordingly. Yes, if
in
it
a
is,
table, in a step function graph.
yes. If in a step function graph, it is given that your probability, like you are made that step function, and you are given that
Hello,
Hello.
somebody
Yes,
speaking.
yes, you.
Yeah.
Yeah. Yes, yes. Hello. So actually, you the connection. I think stopped. Like there was some connection issue.
am
Like
I
if
aud-
I, yeah, you are audible, but your voice is cracking. Hello, am I audible?
Yeah, you're audible.
Yeah, sir. Actually, I think there was some connection problem. Yes, sir. You were telling about the step function graph. Yes.
yeah, am I audible now?
Yes,
Yes, sir.
sir.
Yes, sir. You are.
Okay. So what happens is, suppose you have got this, you have formed your this step graph, right? Suppose
Yes,
at
sir.
2 your graph is having a value, say 3 by 4. Okay.
Yes, sir.
And you want to calculate the probability of x equals to 2. And
Yes.
suppose at 1 your graph is at the level 1 by 4, right? So
Yes.
probability of x equals to 2, it will be that difference, 3 by 4 minus 1 by 4.
Minus 1
Okay.
by 4. Oh, got it.
Exactly, that will be there.
Oh, thanks.
So are you all able to see this paired x slides? Are they visible?
Yes, sir.
Yes.
Now, next question, yes. Okay, is everyone done with the solution? Anyone
Yes, sir.
still? I've got
So
not.
just a minute, sir.
Yes, sure.
Done, sir.
Okay, anyone still solving this? I haven't got much responses for this question. Let's see. Okay, is a variety. Okay. For y equals to 2.44. This cannot be right. Fraction. We cannot have fraction in this question. We have not asked the probability. What we have asked is the random variable, value of the random variable, the random variable that has been defined in the question. So you might want to recheck your solutions. Okay. So what the question has asked is that we have a vessel. There are four black and 5 white balls. Okay. Now 4 balls are transferred into an empty vessel. From these total of 9 balls, what we take is we take 4 balls and we transfer them into another empty vessel. Now our random variable given by y has been defined that it represents the number of black balls which are transferred. Okay. Now, since we have transferred 4 balls, the number of black balls that can be transferred will be either no black balls 0 or 1 black ball, 2 black ball, 3 black balls, or 4 black balls. So these are the values that our random variable will take. So what the question has now asked is what value of the random variable will have the maximum probability. So we know how many balls we have. We know what our random variable is. We know what values this random variable can take. So what we need to do is calculate these probabilities, respective probabilities for each of the cases that can happen in this question. Okay, now let us define the events. Either there will be 0 black and all 4 white balls, right? Or 1 black, 3 balls, because we are transferring 4 balls. Or the case can be that we are transferring 2 black and 2 white balls, or 3 black and 1 white ball, or all balls can be black. Now, probability of y equals to 0. This means that our probability that all the transferred balls are white. So how many white balls we have? 5 white balls. So that will be 5c4. We will choose 4 balls from those 5 balls, and total how many cases we will have? That will be 9c4, right?
9c.
Exactly. So this will be 5 over 126. Solving these value of 5c4, 9c4. I hope you all are pretty comfortable with solving these. Okay, so this is equal to 0.039. Similarly, we will calculate this y for all other cases. That is y is equal to 1. That means from the 4 black balls, we are having 1 black ball. And from the 5 white balls, we are having 3 balls, total of 4 balls. And total what we have 9 balls. From then we are choosing 4 balls. So solving these, it will give 40 over 126. That is this. Or y equals to 2. What is the probability of our random variable taking the value equals to 2? That is, we are choosing 2 black balls. From the 4 black balls, that will be 2. 4 choose 2 into 5 choose 2. From the 5 white balls, 2 white balls, and over 9c4. This will be 1.476. And our probability of y taking value equals to 3. That means from the 4 black balls, we will have 3 black balls. If we have 3 black balls, then one of the ball has to be from white balls. Therefore, 5c1. Substituting the values after solving, it will be 20 over 126. That will be on solving 0.158. And the last case will be that all 4 balls transferred will be from the black balls. That is 4c4 into 5c0. Now, why we have mentioned this 5c0 is basically equal to 1, but sometimes it's better to write this 5c0 because it gives us an idea what we have done, how we have thought of this like this selection. We have selected 4 black balls from the 4 black balls, and we have selected no ball from the white balls. So total of we got 4 balls. Total will be still 9c4. Substituting the values 4c, nc, n is 1, nc0 is 1. So it will be 1 over 0.126, that will be 0.0018. So we can see clearly from this our probability is maximum when our y is equal to 2, that is 0.476, right?
Yes.
Hence, the solution for this question is y equals to 2. Now let's compare the responses again. Just a moment. It's taking a while to go back. Y equals to 2. Okay, y equals to 2 is the response by given the majority of you. So that indeed is the correct solution for this question. So that was all for this session. I hope this week 9 is treating you better than week 8 was.
So can we ask one question?
Yes, yes, definitely.
Yeah, can I, if I take, can I take this as a binomial distribution?
Okay, I don't want to discuss binomial distribution right now because most of others might not have gone through binomial distribution. So when we'll come to binomial distribution, we will look at this like in detail.
No,
okay?
I'm just asking, if I do it, I also resolve in that way, and I also got the answer too.
Binomial, basically you'll have two values, right? Binomial. So you know, if you have studied binomial variable, binomial distribution in the, which is for others, I'll just let you know that is in the upcoming weeks. No need to worry about that right now. This is the how we are approaching this question right now. When we look at binomial distribution, we will see if this is a binomial distribution or not, what this is. As of now, no need to think about that. Yes, we'll discuss that. Yes, you might be right. Okay, we'll just discuss that, not right now. It will be better to not discuss that right now.
Thank you, sir. Good night.
Any other doubts?
No, sir.
Okay. So I'll just end the session now.
Thank you, sir.
Okay. Thank you, everyone. Goodbye.